Welcome back to question 5 of our falling body problems. This time the question reads, you are observing steel balls falling at a constant velocity in a liquid-filled tank. The window you are using is 1 meter high, and the bottom of the window is 12 meters from the bottom of the tank. You observe a ball falling past the window, taking 3 seconds to pass the window. In part A, calculate the time required to reach the bottom of the tank after the ball has reached the bottom of the window. This one's actually quite simple. So if we draw a picture of a window, let's make a rectangular. The height of this window is 1 meter, and it takes 3 seconds for this ball to pass the window. So let's say it's out of sight. It takes 3 seconds to do that. To find the speed, you take the distance and divide it by the time. The distance is 1 meter divided by the time of 3 seconds. Now, they're asking for the time it takes for the ball to reach 12 meters down. So if the speed from here to here is 1/3 meters per second, and there are how many more? 12 meters down. All you do is you take this rate, right now is meters per second, you take it and you make it 3 seconds per 1 meter. And you multiply it then by 12 meters. Look what happens to the units. This meter unit and this meter unit cancel out, leaving you with only seconds. So 3 times 12 is 36 seconds. In part B, the tank is filled with a different liquid, causing the acceleration in the tank to be 6.0 meters per second squared, and the time to traverse the window is 0.4 seconds. Calculate the height of the liquid above the window, the time to reach the bottom of the tank, and the velocity of the ball when it reaches the bottom of the tank. To do this problem, let's draw a picture again. We have the window being 1 meter, and the distance from the bottom of the window to the bottom of the tank is 12 meters. Now we've been given some insight that there is a distance above the window, and that's one of the things that we're looking for, the height of the liquid above the window. So to answer these 3 questions, let's begin by calculating the velocity at the top of the window. So when the ball reaches the top of the window, what is the velocity then? And to do that, we'll be using this formula right here. This formula relates the initial and the final distance. So the initial and the final distance of the window, the initial distance was 1 meter up. That means I'll replace this with 1. The final, let's say at the bottom, is 0. So 0 minus 1 is -1. And that's equal to the right side, the velocity is what we're looking for. So I will leave that blank, and it's being multiplied to the time. We're told in the question that the time is 40 seconds to clear that window, to traverse it, plus the acceleration is, as per the question, 6.0 meters per second. And since the balls are falling down, then we will write down -6.0 meters per second, because we're taking into account the direction of things going downwards. And that's being multiplied to the time raised to the power of 2. So 0.40 squared. Let's solve for V initial. We'll take that expression over this whole thing. So I have -1 minus, because if you take the whole expression over, it becomes minus 0.5 bracket -6.0 bracket 0.40 raised to the power of 2 close bracket. That gives us -0.52 on the left side, and on the right side we still have this term remaining. We'll divide both sides by 0.4. So I'll divide this by 0.4, and I end up with a velocity of -1.3 meters per second squared. The fact that it's negative suggests that the ball is going downwards. So that is our initial velocity at the top of the window. The next thing that I want to do is find the velocity at the bottom of the window. Therefore, we are looking for this. And let me just do my work on the side here. We have v squared, the final velocity at the bottom of the window, is equal to the initial velocity of -1.3 raised to the power of 2 plus 2 times -6.0, and we have -1 because 0 minus 1 is -1. Let's find out what that is. Bracket -1.3 raised to the power of 2 plus 2 bracket -6.0 times -1. That gives me 13.69. I square root this. I get two values for v, -3.7 and +3.7. Again, we'll be using the negative version moving forward. That's -3.7 meters per second. That is the speed at which the ball is falling at this point. Lastly, I want to find the time that it takes the ball to reach the bottom of the tank, and that will answer one of the three things that they wanted, the time it takes to reach the bottom of the tank. To find that out, I'll be using this formula again. So I'll do my work on the side. The bottom of the tank is represented as 0, and at the bottom of the window is 12. So 0 minus 12 is equal to the speed which we just found here, which was -3.7. -3.7 times the time which we're looking for, plus 0.5, and that acceleration was -6.0 t squared. This is a quadratic, because if I move this -12 over, I get -3.0 t squared. I simplified this term. Minus 3.7 t plus 12 is equal to 0. This is a quadratic, so we should get up to two solutions. And rather than using the quadratic formula, I'll just use my calculator. It has the feature already. -3.0, -3.7, and 12, +12. We get two t values, one being 1.476 seconds, and the other t value being -2.7. We're going to reject that because it doesn't make sense in the context of the question. So what we just found right there is the time it takes the ball to travel from the bottom of the window to the bottom of the tank. One of the other questions was calculate the height of the liquid above the window, this height. We will use this formula again, and specifically we are looking for x sub 0. So that's x sub 0, and that's x. I have the final velocity, which I found already. What did we say it was? -1.3. So I have -1.3 squared is equal to the initial velocity raised to the power of 2. Let's assume that the ball was thrown at an initial velocity of 0, so that gets rid of that part. 2 times -6.0 times 0 minus what we are looking for. Let's solve for that. -1.3 raised to the power of 2. Multiply these two out, gives us -12. So I have -12.0 times -x sub 0. Divide both sides by -12, and we should end up with the distance. So -1.3 raised to the power of 2 divided by -12.0 gives me a value of -0.14. And remember, we still have that negative here, so if we divide both sides by -1, that makes 0.14 as our answer. So the distance from the top of the tank, the very top of the tank, is 0.14 meters. That's 140 centimeters. And to answer the last question, where we want to find the velocity when the ball strikes the bottom of the tank, I will use this formula, and we're looking for v. So have v is equal to the velocity at this point, which we had found to be -3.7, plus the acceleration of -6.0, and the time 1.47. Multiplying these two terms and combining everything, -3.7 plus -6.0 times 1.47 gives me a final velocity of -12.5 meters per second. So that's the speed at which the ball is when it touches the bottom of the tank. There you have it. Another question relating to falling body problems.